Hello students, welcome to Easy Elimu Learning Simplified and welcome to this lesson. In the previous lessons we discussed types of quantities and we said we have basic quantities and derived quantities. Examples of basic quantities we discussed, one of it was mass, whose SI unit is kilogram and represented by kg. And then when we were discussing derived quantities, we said these are quantities which are derived from other basic quantities by either multiplication or division. And we mentioned a good example as density. So in this lesson, we are going to discuss mass, which is a basic quantity, and the density, which is a derived quantity of mass, which you are going to see. My name is Albert. I hope you are enjoying the lessons. By the end of this lesson, I expect you to be able to define mass and define density with their correct SI units and subunits. So we are going to see units and subunits of mass and density, and then explain how to measure mass and the instrument used to measure mass. Convert units of density. We are going to convert units from SI unit, which is kilogram per cubic meter. We are going to convert it to grams per cubic centimeter. So we are going to see how we are going to interconvert that. And then finally, calculations involving density. We are going to handle few examples which involve density, and in this case we are going to see the relationship between density and mass, like density, which we call that simple, is equals to mass over volume. So density is a derived quantity of mass and volume. That's what we are going to learn as we proceed. Now, what is mass? Mass is defined as the quantity of matter in an object, and this quantity of matter depends on two factors. First is the size of the object, and then secondly is the number of particles in the object. Now, mass, as we said earlier in the introduction to measurements 1, it's a basic physical quantity. Basic physical quantity means it cannot be obtained from any other quantity, but can only be measured directly using a measuring instrument. Its SI unit, just a reminder, is kilogram, which is written as kg. Now, students, be very keen. When you are asked to state the SI unit, you state the SI, you give the statement kilogram, but kg is not the SI unit of mass. This is a simple for SI unit. It's not the SI unit of kilogram. It's only a simple for SI unit of mass, which is kilogram. Now, other commonly used units are grams. So sometimes we use grams to indicate mass, and we are going to see that the relationship between kilograms and mass is that 1 kilogram is equals to 1000 grams. This relationship is very important. Now, we have multiples and some multiples of kilogram because sometimes mass is so big such that it's more than a kilogram, and sometimes it is so small that we cannot use a kilogram to indicate the exact mass. So we have multiples and some multiples, and the first multiple and some multiple is that 1 kg is equals to 1000 grams, 1 ton is equals to 1000 kgs, 1 gram is equals to 1000 milligram, and then 1 kg is equals to 100 or 1 million milligrams, and then 1 ton is equals to 1 million grams. Now, how is mass measured? Mass is measured by an instrument we call a balance, and when there are many we call them balances. Now we have two types of balances. The first one is what we call the top pan balance, and this one is electrical type. It uses electricity. Either you insert it on a socket or you use a battery, so it's an electrical type, and we are going to realize that it's very accurate. It's very accurate. It uses electricity and it's very easy to use. Then we have the second balance, which is now mechanical type. Mechanical means it does not use electricity. It's a beam balance. So the second one is a beam balance, where you put a mass of known quantity here, or a known mass on one side, and then you compare it with the mass of a known on the other side, and when they balance out, then you will we will conclude that the mass is the same. So if you put 1 kg here, then you put some meat on the other side, then it balances out. In that case, you have measured 1 kg meat. So we call that mechanical balance. And then finally, we have what we call a lever balance. Lever balance is also a mechanical type, meaning it does not use electricity. Just as I mentioned, electrical balance has more advantages to mechanical balances. In this case, means those which use electricity, that is the electrical balance on the top and balance, has more advantage than mechanical balance, because the electrical balance is more accurate. Accurate means it can measure even some milligrams, because it has a digital scale. And then another advantage of electrical balance over mechanical balance is that it is easy to use than a beam balance. This one has a scale you don't even struggle to use. So long as you put your solid there, the one that you want to measure its mass, it will just indicate on the scale the mass that you have. Now, can we move to the next part, that is density? What is density? Now, density, we are going to define it as the mass per unit volume of a substance. Mass per unit volume of a substance, and it's denoted, the word denote, it is denoted by a simple letter or a Greek letter rho, which is written like this. So, from the definition, we can write down the formula for mass or for density. Density, look at the definition, is mass per unit volume. So we can write it as density is equals to mass per volume. So now if we use simples, then it will be density, which is rho, is equals to mass, which is written as m, over volume, like that. So that is the definition of density. So if you have mass and you have volume, you can get density. If you have density and you have mass, you can get volume. Like if you need now volume, it will be mass over density. And then if you need mass, it will be density times volume. So it's very important to note how you can mingle out with this formula. Another important thing to note is that since mass is measured in kg and volume is measured in cubic meter, then the SI unit will be kilogram per cubic meter. This is true because look at this. Density, we have said, is equals to mass, which is measured in kg, and then over volume, which is measured in a cubic meter. Then if we need now the SI unit, we will use the two units of mass and that of volume. Then it will be the symbol for SI unit in this case will be kg per cubic meter, which is written as SI unit as kilogram per cubic meter, like that. So we are going to use this formula to find or to calculate different or to do different questions. So be keen on it as we move forward. So what are the other units for measuring density? Density sometimes is measured in grams per cubic centimeter, which is written as a gram per cubic centimeter. And the relationship between gram per cubic centimeter is that 1 gram per cubic centimeter is equals to 1000 kilogram per cubic meter. But how is that possible? We can prove that if we can write 1 gram per cubic centimeter in another way, in this per means division, then we can write as 1 gram per 1 cubic centimeter. If we convert grams to kgs, remember we said 1 kg is equals to 1000 grams. Then if we need now 1 gram in terms of kgs, we will take 1 divided by 1000. It's going to give us 0.001 kgs. So the mass we have here in 1 gram is 0.001 kg. Then you divide by 1 cubic centimeter. Can we convert 1 cubic centimeter to, can we convert it to SI unit, that is cubic meter? Remember we said 1 cubic meter is equals to 1 million cubic centimeters from volume. Remember what we discussed. Then now if we have 1 cubic centimeter, how many cubic meters are there? So it will be 1 cubic meter times 1 cubic centimeter all over 1 million cubic centimeter. Now cubic centimeter will go with cubic centimeter, then our answer will remain in cubic meter, and in this case it will be 0.0000001 cubic meter. So that is the relationship between 1 cubic centimeter to 1 cubic meter. So in this case we will divide by 0.00001 cubic meter. And now let's now solve this one. For us to get or to remove this decimal from down here, there are 1, 2, 3, 4, 5, 6. We multiply by 1, 2, 3, 4, 5, 6. And then both on top we multiply by 1, 2, 3, 4, 5, 6. So in this case, our answer will be 0.001 kg over times 1000 times 1, 2, 3, 4, 5, 6, like that, over 1 cubic meter, because these decimals have cancelled. These decimals down here we have multiplied by 1000 on top and down, then it has removed these decimal places. Then now this one will remain as these three zeros will take the 3 decimal points, 2, 3, and then we will remain with 3 zeros here. So it means it will be 1000. Let me use a blue pen. It will be 1000 kgs. Remember the units up here is kgs, and down here it is cubic meter per cubic meter. So in that case, we would have proved that 1 gram per cubic centimeter is equals to 1000 kg per cubic meter. That relationship is very important and you need to note it keenly. Now, generally, what we are saying is that to convert grams per cubic centimeter into kg per cubic meter, you multiply by 1000. For example, if I give you 2 grams per cubic centimeter, convert it to kg per cubic meter, then you multiply by 1000, then you will get 2000 kg per cubic meter. Then to convert kg per cubic meter to grams per cubic meter, then you divide by 1000. Like if I give you 2000 kg per cubic meter and I want you to convert to gram per cubic meter, what you do, you take your 2000, you divide by 1000, then you will get 2 grams per cubic meter. So as you can see, we started with this one, we converted to kg per cubic meter, and then we came to this, the one that we have converted, we have changed it back to grams per cubic meter, which it was. Now let's do a few examples. Convert 5 grams per cubic centimeter to kilograms per cubic meter. What we have said, for you to convert grams per cubic meter to kg per meter cubed or cubic meter, you just take your value in 5 grams per cubic centimeter, then you multiply it by 1000, then it will give you 5000 kgs per cubic meter. As simple as that. Convert 13,600 kg per cubic meter to grams per cubic meter. What you do here, you divide by 1000 when you want to change it to grams per cubic centimeter. So here you take 13,600 kg per cubic meter, you divide by 1000, and in this case it will be this 0 will go with this one will go with this one will bring a decimal point there, and then your answer will be 13.6 grams per cubic centimeter. Now students, I hope now you can handle the remaining 2 questions. Please try to handle question 3 and question 4, and if you get any difficulties, remember all solutions are found at ECLIMU website. The link is down there. Then when you visit there, you will get all the solutions ready waiting for you. So let's do the other question concerning density. And the question reads, the first question reads, the mass of 25 cubic centimeters, this is the volume of ivory, was found to be, mass now, was found to be 0.045 kgs. Then now the question is, calculate the density of the ivory in SI unit. So the first thing to do, you make sure you work with either SI unit or you convert them to have uniform units. If you are using centimeter cubed, then here it must be grams. If you are using kg, it must be meter cubed. So let's convert kg to grams. Then it will be 1 kg is equals to 1000 grams. Then we have 0.045 kgs. How many grams are there? In this case, it will be mass is equals to 45 grams, and our volume is equals to 25 centimeter cubed. Then now density is equals to mass over volume. Then in this case, if we feed directly, it will be 45 grams over 25 cubic centimeter, which is going to give us 1.8 grams per cubic centimeter. Then if we want to convert it to SI unit, then we said when you have grams per cubic centimeter, you want to convert to kg per cubic meter, you multiply by 1000. So our answer will be 1.8 times 1000, which is going to be 1800 kg per cubic meter. Then the sixth question is the density of mercury. So you have density, you have to write down what you have is 13.6 grams per cubic centimeter. Then find the volume. We are looking for the volume, we don't have it, of 2000, and the volume of 2720 grams of the mercury. So this is the mass. So we have the mass, and then from density is equals to mass over volume. So we have the mass, we have the density, we are looking for volume. Then in this case, our answer will be volume is equals to mass over density, which is going to be 2720 grams over density, which is 13.6 grams per cubic centimeter. Remember, this one is now going to give us 200 centimeter or cubic centimeters. So remember, this gram will go with the gram, and then this one will go up, and then we will get 200 cubic centimeters. So students, that marks the end of our lesson today. In our next lesson, we will discuss time as a basic quantity. And welcome to EC Elimu Learning Simplified.